Hello everyone. Here in this class, we are going to discuss about reflexive relation. Particular in this class, we will learn definition of reflexive relation and try to understand the definition of reflexive relation with solving at least two or three example on reflexive relation. Let us first we know that see the definition of reflexive relation. Here, if R is a relation in a set A, what is a relation? When you say that R is a relation in a set A, this concept will be discussed here in this class also. And for every A belongs to A, that implies ordered pair A comma A belongs to R. What it means? For every element in the set A, that ordered pair must be there in relation R. Then R is said to be re- re- reflexive relation. I repeat this definition once. If R is a relation in a set A and for every A belongs to in set A, that implies ordered pair A comma A belongs to relation R, then R is said to be a reflexive relation. Okay, we try to understand the definition of reflexive relation with an few more example. Let us we consider set A is equal to 1 comma 2 comma 3. If R is a relation in a set A, when you say that R is a relation on a set A, if R is subset of A cross A, here note to 2 points. One is R is a relation on a set A, and second one is A cross A. A cross A is nothing but what? Ordered pair from set A. When you say that R is a relation on set A, R is a subset of A cross A is nothing but every element in the set R are there in A cross A, then only you say that what R is the relation on set A. Here we want to write A cross A. By this time, you know that familiar to how to write A cross A. So here observe here A cross A is equal to how to write? Take element 1 from set A, we will pair with all element in the set A. That is ordered pair 1 comma 1, 1 comma 2, 1 comma 3. And take second element in set A 2, that is 2, we will pair with all element in the set A. That is ordered pair 2 comma 1, 2 comma 2 and 2 comma 3. And obviously we can to take another element in set A, that is 3. We will pair with all element in set A, that is ordered pair 3 comma 1, 3 comma 2, 3 comma 3. This is A cross A set. The return set is what? A cross A. On basis of A cross A set, we can to define some more relations on set A. So let us, I will take set R1 is equal to ordered pair 1 comma 1, 1 comma 2, 1 comma 3. Is R1 is a reflexive relation on a set A? First, we must check that R1 is a relation on set A. What you say? First, you must check that what R1 is relation on set A. When you say that R1 is relation on set A, every element in the R1 are there in the A cross A. First you check that ordered pair 1 comma 1 is there in A cross A? Yes, is there in A cross A. Ordered pair 1 comma 2 is there in A cross A? Yes, is there in A cross A. Ordered pair 1 comma 3 is there in A cross A? Yes, is there in A cross A. So all the element in the set are there in set A cross A. Then only you say that what R1 is the relation on set A. After we conclude that R1 is the relation on set A, then we need to find whether the given relation R1 is a reflexive relation on A or not. So how to check that for condition of reflexive relation? For every element in set A, how their ordered pair must be there in relation R, then R is said to be reflexive relation. Otherwise, it is not reflexive relation. So now it check it relation R1. We take that element 1 in set A, have ordered pair 1 comma 1 is there in R1? Yes, is there in R1. Can you say about that R1 is a reflexive relation on set A? No, we could not to say, because every element in the set, every element in the set have ordered pair must be there in relation R1. Then only you say that R1 is the reflexive relation on A. So next we check that what element 2 in set A have ordered pair 2 comma 2 is there in relation R1? No, is not there in relation R1, which is not the part of R1 relation, and it fails to condition for every element in set A have there must be in relation R, then R is reflexive relation, but this condition is fails to ordered pair 2 comma 2 is not there in relation R1. That's why we called as what R1 is the not reflexive relation on set A. How to write answer for this? For 2 belongs to A, the element 2 belongs to A, have ordered pair 2 comma 2 is not belongs to R1. That we called as what? R1 is not reflexive relation on set A. So let us we consider one more example on reflexive relation, which is easy to understand the definition of reflexive relation. So R2 have the ordered pair 1 comma 1, 1 comma 3, 2 comma 2, 3 comma 1. The first you check that whether the set R2 is relation on set A or not. So same procedure will be followed as per the above example. So let us check that every element in the set R2 are there in set A cross A. So check it ordered pair 1 comma 1 is there in A cross A? Yes, is there in A cross A. Ordered pair 1 comma 3 is there in A cross A? Yes, is there in A cross A. Ordered pair 2 comma 2 is there in A cross A? Yes, is there in A cross A. Ordered pair 3 comma 1 is there in A cross A? Yes, is there in A cross A. That what it means? Every element in the set R2 have therein set A cross A. Then R2 is said to be what? Relation on a set A. And after we conclude R2 is a relation on set A, we need to check that whether R2 is reflexive relation on set A or not. How to check that? By using condition for reflexive relation. For every element in set A have ordered pair, there must be in relation R, then R is said to be reflexive relation. Otherwise, it is not reflexive relation. So check that every element in A. So we take element 1 in set A. Have ordered pair 1 comma 1. Is there in R2? Yes, is there in R2. Can you say about that? The set, sorry, the relation R2 is a reflexive relation on set A? No, we could not to say about that because every element in the set A, every element in the set A have ordered pair must be there in R2. Then only you say that R2 is a reflexive relation on A. And again you check that what the element 2 in set A have ordered pair 2 comma 2 is there in R2? Yes, is there in R2. And obviously you check that element 3 in set A have ordered pair 3 comma 3 is there in R2. You check that clearly. No, is not there in R2, and which is not the part of R2. So that's ordered pair. It spells to condition for reflexive relation. That is for every element in A have ordered pair must be there in relation R. Then R is said to be reflexive relation. So how to write for this answer? For 3 belongs to A, that implies have ordered pair 3 comma 3 does not belongs to R2. Then what you say? That is R2 is not reflexive relation on A. And we consider again one example on definition of reflexive relation. Set R3 is equal to have ordered pair 1 comma 1, 1 comma 2, 1 2 comma 2, 2 comma 3, 3 comma 3 is R3 is reflexive relation on A or not. How to check that? The first we know check R3, the set R3 is relation on set A or not. So we will be applying for same procedure as per the above two examples. Now here when you say that R3 is relation on set A, every element in set R3 have therein A cross A. Obviously, every element in set R3 are there in A cross A because which is also a subset of A cross A. Then you called as what? R3 is a relation on set A. And after conclude that R3 is relation on set A, we need to check whether the given relation R3 is reflexive relation on set A or not. How to check? By the definition of reflexive relation, for every element in set A, have ordered pair must be there in set R, then R is said to be reflexive relation. Otherwise, it is not reflexive relation. So, okay, now we check it for element 1. We take that element 1 have ordered pair 1 comma 1 is there. Yes, is there in R3. And element 2 have ordered pair 2 comma 2 is there in R3. Yes, 2 comma 2 is there in R3. And again, obviously, we check that another element in set A, that is R3, have ordered pair 3 comma 3 is there in R3. Yes, is there in R3. Every element in set A have ordered pair must be there in relation R3. Then R3 is called as what? Reflexive relation on set A. Okay, how to write for answer this? For every, we not taken a particular ordered pair because this relation is satisfied the condition of reflexive relation. So we can to write it for this answer generally. For every A belongs to A, that it means every element in the set A have their ordered pair must be there in relation R3. Then relation R3 we can to say about that reflexive relation on set A. Okay, until up to this point we have discussed the definition of reflexive relation and example on reflexive relation.